Hello everyone, so welcome to my playlist on multiple integration. So in the last lecture we saw the notion of triple integration, and at the end I took two examples. And what was the observation we took from those two examples is that whenever you projected that surface in any of the coordinate planes, xy plane, yz plane or xz plane, you always got the same projection. That means for cuboid you always got rectangles as the projections. For the part of tetrahedron which we took, for that we always got triangles as the projections in all the three coordinate planes. So now the question is, will you always get the same projections when you project on three different coordinate planes? Answer is no. So today I am going to take one example where we will see that you will get different projections for different coordinate planes. Okay, and I will also take the help of GeoGebra because every time it's not easy to sketch the figure. I mean, for that you need to visualize, but even if you're not good at visualization, don't worry, software is there to help you out. So I will take help of GeoGebra to explain you the concept. And second example will be that will help you to realize that why choosing the order is important. Okay, so these are the two examples I'm going to discuss today. So let me take the first example. So suppose if you have a cylinder, say x square plus z square equal to 4. Now why I'm saying this as a cylinder? See, we are in a three-dimensional space. So this circle becomes a cylinder in three-dimensional space. How come? See, what is x equal to 3 in one-dimensional space is nothing but a point, right? But if I say what is x equal to 3 in two-dimensional space, you will say directly it's a line, right? You pull this point upward, you pull this point downward because your y is varying, right? So your x equal to 3 is a line in R2. What is x equal to 3 in R3? It's a plane. Now your z will also vary. So x equal to 3 is a plane in R3. Similarly, when I say x square plus y square equal to 4, you draw a circle in xz plane and then simply pull the circle and you get a rod or a cylinder. So suppose, this is our xy plane, origin, positive x-axis, positive y-axis, positive z-axis. Now you have a circle where you have a circle in xz plane, so x-axis and z-axis. So this is origin, right? So you have a circle of radius 2 in this xz plane. So in this xz plane you draw the circle of radius 2. And now your y is varying. So you pull your circle over here and you pull your circle over here. So what you get is you get a rod over here. Mathematical term for rod is cylinder. So you get this infinite cylinder over here, the horizontal one. Suppose you want the vertical cylinder. So you take a circle in xy plane. Suppose you take a circle of radius 2, x square plus y square equal to 4. So you draw the circle of radius 2 in xy plane. And then you pull the circle up and you pull this circle down. So you get the vertical rod or the vertical cylinder. And if you want this kind of horizontal, then you draw the circle in xz plane. You pull the circle here, you pull the circle here, you get the rod like this. And all this called is right circular cylinder because they make an angle of 90 degree. If you have such a cylinder over here, then that's not a right circular cylinder. Okay, so that's why when I am writing this equation, I am saying it's a cylinder in a three-dimensional space. Okay, now this is a cylinder, and suppose you want to find the volume which is in first octant, and suppose your y is equal to 3. Now question is how the surface will look like. So let's try to sketch the figure. So I know that it's a cylinder over here. So this is my suppose xyz over here. Now it's a circle in xz plane. So this is my xz plane. So you draw the circle over here of radius 2. At the back I don't mind because I'm in the first octant. Okay, and then you're going till y equal to 3. So you go till here. You go till here. So this is what you have, and here you have like this part of the cylinder. So as you can see, this is the curved part. Okay, so you have to find the volume below this cylinder and above this region. You can also do this by double integration. If you want to do this by double integration, the hint I am giving you is your function, since we are in first octant, so square root of 4 minus x square, suppose your dy dx. What is dy dx? It's a rectangle over here. So projection, I mean here you have a rectangle in the region, so your y will go from 0 to 3, x will go from 0 to 2. But that's okay, I won't be doing this by double integration. Let me tell you using triple integration. So if you want to solve this by triple integration, we know that we take function to be 1 and you choose any order, let's say dz, dy, dx. Now to find the limits of z, what do? You draw the line parallel to z axis. So when you draw the line parallel to z axis, it will enter from here and it will come out from the surface. So it is entering. So okay, let me show you over here also. So this was my xy plane, z axis. So this is the kind of dome over here, kind of dome, half part of the dome. So when you draw the line parallel to z axis, it will enter from xy plane and it will come out from this dome shape, kind of, which is nothing but my cylinder. So my z will start from 0 and it will come out of root of 4 minus x square. Now when you do the projection in xy plane, what will you get? When you do the projection in xy plane, this is what the rectangle you get. This is what you have. And you know what are the limits for rectangle? Your y is going from 0 to 3, x is going from 0 to 2. You solve this, you get the answer. Now if you take the order as triple integration 1 times dy, dz, dx. Suppose if you take this order. Now if you want to draw the line parallel to y-axis, what you do? To find the limits of y, you draw the line parallel to y-axis. So your line will come like this. It will enter from here and it will come out from here. This is y equal to 3 plane. It is entering from xz plane. On xz plane, your y is 0 and it is coming out from y equal to 3. Now when you project this on xz plane, what will you get? So when you project everything over here, this is the part of circle you get. So this is the projection onto xz plane. Okay, and if this confuses you, you draw separately. This is my x, this is my z. You are in first octant, so projection will be in the first quadrant, 2, 2. So this is the projection you get. And now you know how to solve this. What are the limits of z? You draw the line parallel to z axis. So your z is going from 0 to root of 4 minus x square from this relation. And what is your x? X is going from 0 to 2. So that's how we can see if the projection might change. For yz plane, the projection will again be a rectangle, so that's not a problem. So here also when you project on yz plane, that means if you choose the order of integration as dx, dy, dz, then in yz plane you again get a rectangle. Okay, so that's how. Okay, I won't be solving this integration. Your first homework is you have to tell me this volume. What is the volume of this surface? What I want to tell you is how to see this using GeoGebra. So now when you go to this GeoGebra website, now here if you click on this square dots, you go to 3D calculator. Now once you are in 3D calculator, first thing is you give the equation of the cylinder. Now since it's in the first quadrant, I will give z equal to square root of 4 minus x square. Good. So this is the cylinder I have. As you can see, it is in the upper half of the surface, because we want it positive. But now we want the restriction on this. What is the restriction? Our x is also positive. So 0 less equal x less than and equal to sign. It's there on the keyboard. If not, you can click on this virtual keyboard and you can use the symbols whatever you want. But it's okay. So 0 less equal x less equal 2. So that was one thing. And then what was the second thing? Our y. So y was 0 less equal y less equal 3, right? Because it was in the first octant, that's why y greater equals 0 and it was bounded by y equal to 3 plane. And now if you can see, this is the surface. I drew the same thing and now the same thing you can look over here. So you want to find the volume of this surface, the volume below this part of the cylinder. I hope you can see my cursor, and above this rectangle at the bottom. So this is the volume you want to find. Okay, now to find the limits of z, now make sure the axes are clear. The red one is the x-axis, the green one is the y-axis, and the blue one is the z-axis. Now to find the limits of z, what you do? You draw the line parallel to z-axis. Now here if I want to draw the line, you simply type line, you get this. So I will insert 2 points and I will get the line. Because for line, I know once I get 2 points, I can draw the line, unique line. So I want a vertical line. That means what? My which component is fixed? My xy is fixed, my z is changing, right? So my xy is fixed, say 1 1 0, and my z is changing, so say 1 comma 1 comma, let's take 1. And as you can see from here, this line is entering from where? It is entering from this bottom, from xy plane, and it is coming out from the surface, that means the cylindrical part. Okay, so therefore if you try to write down the limits for z, what will you get over here is, so your z was starting from xy plane, so 0, you have less equals z, and it was coming out from the cylinder, and that's what we saw on our whiteboard, right? It was 4 minus x square. And what was the projection? The projection was this part over here. The projection is what? You can see the bottom rectangular part. And for bottom rectangular part, we know my y will go from 0 to 3, x will go from 0 to 2. So that was the obvious thing. Now let's take a different line. Now to find the limits of first y, as we saw earlier on the whiteboard, let's do the same thing. Now to find the limits of y, we draw the line parallel to y-axis. When I am drawing the line parallel to y-axis, my x and which component will change? My y component will change, whereas my x and z will remain same. So my x and z will remain same, my y component will change. So 1 comma 0 comma 1. And now as you can see, this is the line parallel to y-axis. Okay, because my green axis is the y-axis. So as you can see, it is entering from here. What is this? As you can see, it is entering from, it is entering from, okay, let me stop this. Yeah, it is, and so it is entering from xz plane where my y is always 0, and it is coming out from this y equal to 3 plane. So therefore the limits of y were 0 to 3, and when you project this, what you get? You get this part of the curve. As you can see, you get, as you can see, this part, the quarter of a circle in xz plane, and that's what we saw on the whiteboard also. So that's how you can draw with the help of this software, you can draw the line. If you want to draw the line parallel to x-axis, so that means my x component will change 1 comma 1 comma 1, and here it will be 0 comma 1 comma 1. And as you can see, you are having a line parallel to x-axis. It is entering from where? It is entering from yz plane where my x is 0, and it is coming out from the cylinder. So square root of 4 minus z square. So that's how you take the help of the software. You give the restrictions and you get the surface. So that was about the first example. Now for the second example, what I want to say is you should be careful while choosing the order. Why? Because otherwise things might become quite complicated. So suppose if I take this as the paraboloid, z equal to x square plus y square, and if I take another one as z equal to 8 minus x square minus y square. So if you take this two paraboloid over here, and I want to find the volume which is bounded by this two paraboloid, volume bounded by this two paraboloid. So now as you can see, so this is the darker part. As you can see my mouse, this is the volume you need to find. Okay, so I hope this is the volume you need to find, which is clear to you. Now to find this volume, I will need to first find the limits of z. So to find the limits of z, you draw the line parallel to z-axis. So to draw the line parallel to z-axis, your z component will change. Okay, so let me take say 1 comma 1 comma 0 and 1 comma 1 comma 1. And now as you can see, this is the line I am getting parallel to z-axis. From where it is entering from this lower paraboloid and coming out from this inverted paraboloid. Okay, so as you can see, it is entering from this upward paraboloid from here, as you can see my mouse, and it is coming out from the inverted paraboloid from here. So the limits of z will be what? So it is entering from the upward paraboloid, so x square plus y square less equals z, and it is coming out from the inverted paraboloid, so 8 minus x square minus y square. So this will be the limits for z. Now we want to find the limits of x and y, right? So we have to do the projection. So if you see, this is the intersection part over here. Let me expand this. So this is the intersection part over here. So when you project this downwards, that means I want to see what is the intersection of these two surfaces. And how do you find intersection of these two surfaces? You simply equate them, right? So if I equate these two, what I have x square plus y square is equal to 8 minus x square minus y square, and this will give me what? X square plus y square equal to 4. So this is the equation of circle I am having. So in the projection in xy plane, I am getting this circle of radius 2. So this is a circle of radius 2. And you know what are the limits for this? To find the limits of y, you draw the line parallel to y-axis. So the limits of y are minus square root of 4 minus x square to plus square root of 4 minus x square. And now what will be the limits of x? Their x is simply going from minus 2 to 2. So therefore the limits of x are minus 2 less equal x less equal 2. So the order that we have chosen is dz, dy, dx, and using this order your things becomes pretty much easier. Why easier I am saying? Because now if you see the figure carefully, if you first take dx, that means if you try to draw a line parallel to x-axis over here, let me tell you with the help of an let me draw the line itself. So if I take line over here, and if I want to draw the line parallel to x-axis, right? So 1 comma 1 comma 1, and my x component should change, right? So 0 comma 1 comma 1. So it is entering from here, as you can see, it is entering from upward paraboloid over here, and it is coming out from the upward paraboloid only. And whereas if I take the line as, and now you can see, or even if you take 11 also. So let me take 11 so that you can have a proper distinction. Yes. So if I draw this line, it is entering from the inverted parabola, leaving from the inverted paraboloid. Okay, if you want more clarity, you can take 13 also. As you can see, it is entering from where? Inverted paraboloid, leaving from inverted paraboloid. So you need to divide the region into two parts. So this one will be the R1 region and this will be the R2 region. So for here, your limits will be what? It is entering from the upward paraboloid. So your limits of x will be what? So z equal to x square plus y square. So from here, what will be my x? So my x will be nothing but minus square root of z minus y square to plus square root of z minus y square. And what was the downward paraboloid? The downward paraboloid was z equal to 8 minus x square minus y square. And what will be this? From here your x will be minus square root of 8 minus z minus y square less equal x to plus square root of 8 minus z minus y square. So you need to divide the region into two parts. So division was okay, at one shot you can say it was easy, but then what about the projection? When you project this on which plane now? YZ plane, it's difficult to, I can visualize at least, but it's difficult to visualize, right? So therefore choosing order is quite important. So always try to imagine the surface and accordingly choose the order of integration wisely. So now I hope both the examples are clear. Well, for the second example, don't try to solve. In the next lecture, I will tell you something about cylindrical coordinates, and then it will be very easy to solve. In 3 lines, you will get the answer. This will be a bit time consuming, but your homework is you have to answer me the volume for the first problem. So I hope you understood the lecture. If yes, do not forget to like, share and subscribe. Thank you.